Hey everyone, let's look at functions together. Okay, so we want to find the domain of G, and in this first problem, and really the domain, really in its essence, is all the x values we can plug in and get something out, and get any value out. And so let's look at these x values. So we've got, let's see, we can plug in -6. If I plug in -6, I get out 3. If I plug in -4, I get out -3. So those are two values in my domain. If I plug in 6, I get 7. But there's some other values here too. I mean, I could plug in -2 and get 6. I could also plug in, here's something interesting. I could plug in -3 and get 1.5. And I can plug in, I could plug in, I don't know, -1 and get 6.1 or something of that nature. And so we can I can plug in not just these points, but I can plug in all the points in between. I can plug in 5 or 4.5, 6.5, or 5.5. I can plug in -1.5. I can plug in all these values, every single one from 6 all the way to -6, and get some value out. So that's really what's going on here. I can plug in all these values. So my domain is all the x values I can plug in and get something out of. Then my domain is from -6 to 6. So x is from -6 to 6. And where we can write that as a sort of like an inequality is -6 is less than or equal to x, which is less than or equal to 6. It'll always be less than. And because it includes this -6 point and it includes 6, includes both of those, it's less than or equal to. It could be equal to -6. It could be equal to 6. So we have that or equal to sign. So that's the answer. -6 less than or equal to x, less than or equal to 6. Easy as that. How about range? In this range problem, it's a little bit different because let's see, that the range is all the y values I can get out. So if I try to find a y value for -2, I'm trying to find a value. Let's see, can I find a y value? Can I get out a y value at -2? And I guess I can. I can find it at -5. There's a y value for -2. So I can find -2. I can find a y value for -4. I can find a y value for 2. I can find a y value for 4. Find a y value for 6. Because at 4, because the x values for that is 4. At 2, the y value for that is -4. At -4, the y value for that is 2. And so I can find y values for all these things. But here's what I can't do. I can't. There's a lower bound. There's a lower bottom at -4. It's top part at 6. But I can't find the y values in between those. Like I couldn't find a y value for 3. There's no y value for 3 because these lines aren't connected. It's not a bunch of things connected together. It's just 3. 3 doesn't have it. It doesn't have one of those. And remember what we said about lines. Lines don't exist in graphs. It's just a big, huge collection of points. So in this kind of graph over here, looks like there's a line in between, it's actually just a ton of points, just a bajillion points that we're finding. Over here, there really are just, let's see, 1, 2, 3, 4, 5, 6 different points. So we can't find the y values for all of them. Or we can find the y values for all of them. That's all there is. So the y values we can get out are these. We can find out -4. We can find -2. We can find 2 because it's y value for that. We can find 4 and we can find 6. Those are all of them. So we'll just write them all down. So y equals -4, -2, -2, 4, and 6. And that's our answer for that one. Cool. Let's move on to the next one. The next one says this. For a given input value r, the function h outputs a value q to satisfy the following equation. Q minus 10 equals 6 times r plus 1. This is write a formula for h of r in terms of r. Here's what it's saying. Let's first break down what it's saying inside the actual words. It says for a given input value r, the function h outputs a value q to satisfy this equation beneath. what it's saying when it says h outputs a value q, that means that whatever this function h is, it equals q. It's the same thing. It's function h and q will be the same thing. The output of function h and q are the same thing. So if we have an output, if we know what the input is, we know what r is the input, and this we'll find the r is input. If we know what the input is, we'll find out the output. The h of r, the h of whatever it is going to be q. Cool. So h and q in this kind of sense are really similar, almost the same thing. We can say h of r equals q, or h outputs a value, because when h outputs a value of q. Okay, so when it says write a formula for h of r in terms of r, here's what it's asking us to do. It's saying we want to write something where so h of r equals something. But we know that h of r, that h itself, this function, is q. It equals q. So what we want to do to solve it, in order to solve this, what we're trying to do here is find out what q equals. So if we can figure out q, because h of r, again, h of r equals q, if we can replace h of r with q, and we'll say q equals something. If we can find q equals something, then we'll know the answer. In other words, and yet another way to put this is that because q is the output, q in the same way that when like x is the input, and y is the output, y is the output is y. We know most functions, when we write a function, we usually say y equals something. We're trying to graph it. And if we know the output is q, then we'll find q equals something. We'd say y equals something, and same way we write f of x equals something. Now, if we have q equals h of r, we have the same way with h of r, we can say q equals something. So we're trying to, in other words, the point of the matter is the huge thing is trying to tell us here, the big thing we're going to catch is that q is what we're trying to solve for. And if we can solve for q, then we'll have the answer. And rewrite the function so that r is just a variable. Okay, so q minus 10 equals 6 times r plus 1. We will add 10 to both sides. Add 10, so we get q equals 6r plus 1 plus 10. Let's see, that simplifies down to q equals, let's see, that'd be 6 times r is 6r plus 6 times 1 is 6 plus 10. And that reduces down to 6r, 6 plus 10 is 16. So we get 6r plus 16. And that's our answer. So h of r equals 6r plus 16, or q equals 6r plus 16. Great, and that's all there is to that problem. Solving for q, because q is our output. Okay, Tessa's class had a math exam where the grades were between 0 and 10. Sounds like one of my quizzes, doesn't it? The N of G models the number of students whose grade in the exam was G. Okay, so N of G doesn't actually, it's important to notice this at the get-go. It looks like N of G doesn't tell you what the score was. It says given a G, or given a grade, given a G, so it looks like if G is the grade, and then N of G is the number of students that got that grade. Interesting. So the input is grade, input is the grade, and the output is the number of students that get that grade. Okay, so energy would be the number of students that have that grade. All right, that's important. Let's see. So if we say n of 8, or so if I, well, it's not even we're going to get there. So if I say n of 1, that's the number of students who scored a 1. Or if we say n of 10, that's the number of students who scored a 10. Okay, so that's what it's trying to tell us then. So if we say n of 8, okay, so we're saying that would say the number of students, n of 8 right there, that's saying number of students who scored an 8. The number of students who scored 8. Okay, and we're saying is greater than. We know what greater than is. Let's change the colors real quick. We know that this is greater than. Okay, and then let's look at that next bit on the right. We've got, let's see, the n of 5, that's the number of students who scored 5. Okay, so you've got the number of students who scored an 8 is greater than something, and the number of students who scored a 5. Okay, that's 2 times the number of students who scored a 5. So that would be, let's see, let's choose yet another color. That would be 2 times. 2 times the number of students who scored a 5. Okay, so all that together, it's saying the number of students who scored an 8 is greater than 2 times the number of students who scored a 5. Okay, so that means that like if that whoever got an 8, there's probably, maybe if there's like 20 people who got an 8, that's got to be greater than, that 20 has to be greater than 2 times where the number of people who got a 5 in. So that means if like there couldn't be like 11 or 12 people who got a 5, because if 12 people got a 5, I mean 2 times 12 is 24, which means that 24 students, and 24 can't be, has to be less than the 20 of 8. So in other words, the number of students who scored an 8 has to be greater than 2 times the number of students who scored a 5. That's all it's saying. In fact, we could just write that down as our answer. The number of people who scored an 8 is 2 times the number of students who scored a 5. We're done.